number higher or lower? We are playing the guess game. The game is as follows. I pick a number from 1 to n. You have to guess which number I picked. Every time you guess wrong, I will tell you whether the number I picked is higher or lower than your guess. So you have a predefined API, the guess what takes in num, which returns the three possible results: -1 if your number is higher than the number that I picked, 1 your guess is higher than the number I picked, 0 your guess is equal to the number that I picked. Return the number that I picked. So we have our input here, our guess here, and the pick. The pick always comes out guess pick. So we don't have the option to not get the pick. The pick will always be there. So we can easily solve this with a binary search. We can easily and efficiently solve this with a binary search algorithm. So now our time complexity will be O of log n space complexity of 1 space complexity of O of 1, since our numbers will stay, our variables will stay the same without taking any additional space. Complexity. So our two variables in the binary search are always our two starting variables are the left pointer and the right pointer, equals to, here it says from 1 to n, so our left pointer will be 1 and the right pointer will be n. So now let's get into this. So while our left pointer is less than or equal to our right pointer, let's calculate our midpoint. Midpoint equals to our midpoint. I'll just call it mid. Mid is, let me call it middle. Middle, no, I just leave it at mid. So mid equals to right pointer plus left pointer, floor divide division 2. So while we have our midpoint, we have our mid value. I like to call this midpointer. Midpoint. I'll call it midpoint. So let's call this API our guess. Let's call it result, which stands for result. So result equals to guess and then call this our midpoint. So our midpoint will be the num here. So now if our result is equals to, here this 0 means that it's equal to the number, so number let's return mid pointer. Else if, or elif, elif our result is equals to, if it's higher than the number that we picked. If our guess is higher than the number that was picked, then let's keep our equals to -1, return no our right pointer equals to midpoint -1. So if this is the number here, and our guess is over here, like over here, our right pointer from all the way will come all the way from here to this, around this area, after coming here, and so it will come from the midpoint to this, no. So if our right point over here will come over here, if this is our number, let's call this n, and this is our guess over here, and our midpoint value is over here. Our midpoint value is over here. Our right pointer will come to our midpoint, whichever it is, I'm not sure, and then -1, boom, and that'll be our right pointer now. Right pointer. So now what we have left is our left pointer. Our left pointer equals the mid pointer point +1. So let's copy and paste. That will be this case over here. Which one's the 1? But there's no need to specify because that's the only one left. So let's see. Oops, if I can put the midpoint again. Or is there? So our time complexity is O of log n. That's the most efficient that it can be, with the space complexity of O1. And that should work. Let's see if it does. And that's it. Let's submit it and see if it passes all cases. And that's it for this problem. Oh, it bit 99%. And that's it. This is an easy binary search problem.